Do you know you can solve the segment area in 15 seconds? Yes, you are right. We can solve the segment area in 15 seconds. Here I have given a problem. If the radius is 15 centimeters and the substance angle is 60 degrees. We need to find the minor segment area and major segment area. You need not to draw the diagram. I just draw the diagram for your understanding. What is the minor segment area? A green color highlighted is the segment area, right? So for that, we need to take the total sector area, that is OAPB, right? This total sector area minus the triangle area. If we just do this, we'll get this minus segment area, right? So this is what we do here. We just take the total sector area minus triangle area. How do you get the sector area? The circle area is pi r square, right? For theta angle, it should be theta by 360 into pi r square, right? So theta by 360 into pi r square minus triangle area will put. So here I have derived the formula for the triangle area, that is r square into sin theta by 2 into cos theta by 2. In the next slide, I will explain how to get this. It's very simple. Easy. You know the sector area, it's just theta by 360 into pi r square and just subtract minus with triangle area, right? So the triangle area is given is a simple expression to remember. It's just r square sin theta by 2 into cos theta by 2. That's all. Let's substitute here. R is equal to 15 centimeters and theta is equal to 60 degrees. And here you can see that r square, you can take it out. In both terms, we have the r square here. If you take out the r square here, that's become 15 into 15. And inside we have the 60 by 360 into pi minus sin 60 by 2 into cos 60 by 2. If you further simplify it, so 15 into 15, 225. And here 60 by 360 is 1 by 6, right? So it comes as a pi by 6 here. And sin 60 by 2 is sin 30, right? Sin 30 is 1 by 2. Cos 30 is root 3 by 2. So 2 multiplied, you get the 4 here. So root 3 by 4 here. So you can see here how just in 2 steps we have found the minor segment area. Okay. You can simplify this expression by substituting the pi and root 3. Okay. Now we will see how to get the major segment area. Major segment area is the total circle area is pi r square minus this minor segment area, right? So the minor segment area is written over here. So we just subtract from the pi r square minus this minor segment area. So here also you can take it common, like r square is 225, right? If you take common 225 here, it became like pi minus pi by 6 minus plus root 3 by 4, okay? So 225 in the bracket. Here if you take common 6 actually here, so 6 pi minus pi is 5 pi by 6 plus root 3 by 4. Clear? So now we will see how to get the triangle area r square sin theta by 2 into cos theta by 2. So now I will explain the only triangle area proof over here so that the rest of things you understand in the previous slide. So let's take a circle and draw a chord in that. Mark the chord points A and B and join this to the center of the circle, and that is the radius of the circle, and the angle is suspended, angle is theta degree, and draw a bisecting line, and that is perpendicular to the AB, right? So OM is perpendicular to the AB. Those are the circle property. Okay, in the chord, if you bisect the angle, that is exactly perpendicular to the AB line. So the angle became like half of the angle like theta by 2. That is OAM angle will become theta by 2. What is the triangle area? Triangle area is half into base into height. Yep. So we need to find the AB and OM. Okay. So you know that AB is just 2 times of the AM. Okay. Because it is a equal distance, it will bisect the chord. Okay. Now, if you take this triangle OAM, okay, here M is the 90 degrees, right? So you can write the sin theta by 2 over here, okay? If I write say sin theta by 2, it is AM by hypotenuse OA, right? So AM by OA, okay? So here OA, we know it's a radius, so that AM will become R into sin theta by 2, okay? Similarly, if you write cos theta by 2 here, that is OM by OA. That is the adjacent side to the angle OM by hypotenuse, that is OA here. From here, we can find the OM. OM equal to OA into cos theta by 2, okay? First, we will find the AB. AB equal to the 2 times of the AM, right? So it is double AM plus MB. Both are equal distance, so that we are writing 2 times of the AM, okay? So 2 times of AM can be written from this sin theta by 2, right? It's a OA into sin theta by 2, right? OA is the radius of the circle. So R into sin theta by 2 here. Similarly, OM equal to R cos theta by 2. Okay. Here you can write OM equal to OA into cos theta by 2. OA means R into cos theta by 2 is the OM. If you substitute into the triangle area, of into, here, this is 2R sin theta by 2 into R cos theta by 2. Okay. So 2 get cancelled over here. And R into R, it becomes the R square into sin theta by 2 cos theta by 2. Okay. So this segmented triangle formation here, right? So this triangle area is simply R square into sin theta by 2 into cos theta by 2. I hope you understand well and you like the video. If you like the video, press the like button and share with your friends. Subscribe my channel. You'll see the more interesting problems like this. Thank you.